All right, hello my friends. So we're going to talk about properties of matrices in this video. So let's just jump right into it. So two matrices are equal when they have the same dimension and the same elements in the same positions. So in reality, this might sound like a lot, but I think that this is actually pretty straightforward. So I'll show you like a problem that might try to flex this definition. So what values make these two matrices equal? Okay, so I feel like it's fairly intuitive, right? So if I have 2 plus x, what does this ultimately need to equal? It needs to equal 5. So like it has to be in the same position in each matrix. So if I were trying to like figure this out, what value of x, what value would x need to have, I could just set up this equation, right? And I would get that x must equal 3. Okay, so what about w here? So what would this have to be equal to? 3 minus w would have to be equal to, so again, going to the same position, boom, here, 4. So I have 3 minus w equals 4. So then that's going to give me that negative w equals 1. So that means that w equals negative 1. Okay, now if you feel like you got this, I recommend that you just try these last two on your own before hearing the explanation and then hit play. So I've got 2 minus y equals 7, so that means that negative y is going to equal 5, so that means that y equals negative 5. And then 2 plus z, that needs to equal 3, so again, keeping everything in the same spot. So then that means that z needs to equal 1. Okay, so let's talk about some other operations with matrices. So addition. So you can only add two matrices when they have the same dimension. I feel like this is actually pretty intuitive. I'll show you some examples of this in a few minutes. I want to go through a couple other properties, I guess. Let's talk about subtraction. So matrix subtraction. Let's say that I have two matrices, A and B. So if I take matrix A minus matrix B, the way that we technically think about this is we think about this as A plus negative b. That's the technical definition, but in reality, like when you do matrix subtraction, I think this is actually pretty intuitive. I don't think it's too bad, so I'll show you an example of that in a moment. And then the last thing I want to talk about is scalar multiplication. Okay, so let's say that I've got a matrix A. So there's multiplication and then there's scalar multiplication. And scalar multiplication looks like this. I have k times a. So what this means is that k is a real number, and you just take every element in A and multiply it by k. So this might look like something new, but we'll look at a few examples in a second and we'll explain it all. And just to kind of mention this, so if I have two matrices A and B, and then two scalars C and D, these are whatever real numbers you want. I have a couple properties of scalar multiplication. So scalar multiplication is distributive. So I could take C plus D times A. So I could first add these together and then multiply. Or I could just distribute each of these scalars. So that goes kind of both ways. You can distribute with scalars and with matrices, as you see here. And then scalar multiplication is commutative. So you can take C times A times D, and that's the same thing as CD times A. And similarly here with this other property. So scalar multiplication has its own distributive properties and its commutative properties. I think the easiest way to handle this, now that I've thrown all this at you, is to just practice the operations. Okay, so I have here a list of matrices, and I'm going to just list an operation, and we're going to decide whether we can do it or not. So I've got A plus C. So here's A, here's C. So these are both 2 by 2 matrices, so I can add these. So what I recommend that you do when you're figuring this out for the first time is I recommend that you just write everything out just so you can like visually see it. And then as far as like, oops, and this is plus. And so then as far as like, what do you do? So you just add element by element. So I'm going to take 3 plus 0. So maybe I'll write out all the operations here. So I have 3 plus 0. Then I'm going to have 2 plus 7. 2 plus 7. I'll have 1 plus 1 and 8 plus 3. So you literally just go through element by element to do this. And let's see, I'm running out of space here, so let me clear all of this now that I've written that out. And so this becomes 3, 9, 2, and 11. That would be the result of that matrix addition. So matrix addition, I think, is nice and straightforward, as is matrix subtraction. So I've got B minus D here. Now if I line these up, so let's take a look. 7, 2, 1, 0, 4, and 1. And then I've got 2, 3, 1, 2, 1, and 0. And I am subtracting them, so I'll just put a minus sign there for now. But I think you can see the issue here. These matrices don't have the same dimension, so you can't go element for element. If I take 7, so maybe you'd say 7 minus 2, maybe 2 minus 3, but then what would the 1 get paired with? So everything has to have the same dimension, or you can't do this. So this just does not exist. There's no solution, can't be done. So that's what you're looking out for. And so like I said, I feel like it's kind of intuitive. So let's keep going. So what about B minus E? So this is going to be, again, pretty intuitive. So now I've got my B and my E. Here's B, here's E. So maybe just for the sake of saving some space, so we've got this one, we've got this one. So as you'd probably anticipate, so you're just going to go element by element. So if I just think of what operations I have here, so I'm going to take, here's the 7 in the B minus the 7 here. Next up, I'm going to have 2 minus 2, 2 minus 2, and 1 minus 1. So that's the top row. And then in the bottom row, I'll have 0 minus 1, 4 minus 0, and 1 minus 0. And that's taking each element in here and then subtracting each element in here. And so then it's really just, what's the end result? Well, I have 3 zeros on top, -1, 4, and 1. And so that would be the result. Okay, so now let's talk about scalar multiplication. So I have 2b plus e. Okay, so again, I actually think that like scalar multiplication, this is fairly intuitive once you know what the notation means. This means multiply everything in b by 2. So if I take everything in b and multiply it by 2, it's going to be 2 times 7, 2 times 2, 2 times 1, 2 times 0, 2 times 4, and 2 times 1. So here is 2b, and then I want to add e to it. So here's kind of everything that's happening. And so again, I feel like this is somewhat intuitive. I'll make a little space here to finish this. Okay, so let's see. This will become really 14 plus 7, which is 21. We're going to have 4 plus 2, which is 6, 2 plus 1, which is 3, 0 plus 1, which is 1, 8 plus 0, which is 8, and 2 plus 0, which is 2. So there is everything that is involved with that. Okay, so now that you've seen kind of how all these operations work, I have a little bit of a more challenging problem here for you. I highly recommend that you pause the video, and just to make sure that you've got this, you work this one out entirely and then hit play when you're ready. Remember, math is not a spectator sport. Okay, so let's see. I'll go ahead and just set up what 2a is. So this would be 6, 4, 2, and 16. So I'm taking each element in here, right, and multiplying it by 2 to get this. And then minus 3c, so just what is 3c? This would be 0, let's see, 0, 21, 3, and 9. All right. So now if I finish the subtraction, this is going to give me 6, -17, -1, and 7. Okay, so that is it for this video. So I will leave it there. And the next video, we're going to talk about matrix multiplication. That's a little bit more complicated, so it needs its own video. So I'll catch you guys in that one.